thanks for you guys coming. Today I'm going to talk to you about Swap. I'm an engineer on the Swap project, so I've been helping build out this platform for the past 5 months, and so I'm really excited to share what we've done and what we've been able to build. So the way I'm going to kind of go through this talk, I'm going to keep it casual, so feel free to ask any questions as I'm going through. But I'm going to just start with a brief intro about what is Swap, then kind of walk through our white paper, so that everyone gets a better sense of how the peer-to-peer trading is actually going to take place and what it actually looks like from both where it's interacting with Ethereum as well as what the users are going to be able to see. So to start briefly, what is Swap? Swap is simply just a way to trade ERC20 tokens between two parties. And what Swap provides is that we get a ability to, I guess, find two parties who are willing to trade with each other for different ERC20 tokens, as well as you're able to negotiate a price between those two parties in a private fashion. And then eventually, once a price has been decided on, then we'll actually facilitate the trade of those two, and that's going to take place in a smart contract. So the first step, right, is how do these two parties are able to find each other? And that's going to go through our indexer protocol. What the indexer protocol is it takes place off-chain, and effectively a maker, which is just one side of a trade, and the taker, the other side of the trade, are able to look to the central area and determine what each individual is going to trade. So as an example, a maker would put in, I guess, they have an intent to trade something. So they'll have a I have token, and I'm just going to use the words token A and token B to represent ERC20 tokens, but in actuality they can represent like Augur or Gnosis or Bancor or anything else that follows the ERC20 protocol. So I have token A and would like token B. So what happens is that a maker is going to basically post their intent that they're willing to do this trade. And multiple makers will come in, and you'll almost get a list of various addresses who are willing to trade the same token as well as to buy the token. So that means that you need to be able to sell token A and token B. That's the information that's being put into the indexer. From there, this is what exists for people who are declaring that they want to trade something. Then comes in a second party who's going to be like, OK, I'm looking for someone to trade with. How do you go about doing that? So the taker will say, I would like to find an intent. I would like to find a party who I can trade with. And so they'll list, I would like to, so the taker would actually want the opposite, right? They're going to want token A, and they're willing to trade token B. If there's a match between just that information, the person who's requested a find intent, they would get back the maker address, and from there they can go on to communicate with each other privately, and so there's no central information hub for the actual negotiation of prices. The nice thing about the indexer is that you're not really sharing too much information. All you're sharing is that you have an intent to trade one token with another token. There's no information about price. There's no information about quantity, which are pieces of information that if that gets shared publicly, people could maybe try to manipulate that information or shift intentions and manipulate the system. So that's kind of one nice thing about having an indexer that is fairly broad in that you're not asking too much information. So now we kind of come to, so are there any questions, I guess, at this point about what is the indexer?
I think I just have a question about the understanding of how the taker gets the information about the maker. So just to clarify my understanding, does the taker get the whole list of addresses and gets to pick one, or are they?
That is correct. So if there are multiple, so yes, this example only has a single maker, but in the case that there are, let's say, so if this is an indexer and there's just like, what, five different makers who a taker, if they like request this one value, they would get all those different addresses, and then they have the opportunity to kind of carry forth with our peer protocol to get more information about what is the price, what quantity is the maker able to give them. And again, so we're just giving them a list of addresses. So moving forward, now that the maker, oh, go ahead.
So if there's a list for the makers that the taker looks at, how does a taker determine which maker is the right trade partner for them?
Right, so when a taker is starting out initially, they might not have any information about what kind of price or any information about what maker is going to. And that's the same thing as when you go to a market, you don't know what stalls are going to provide what. You don't know what has like the better price. So really, it's just you have the ability though to just kind of send requests to all of them if you'd like to, and then from there you'll make the determination of who you would like to trade with once you've figured out a price and quantity. Now that we have a maker and a taker, the next step, right, is how are they going to figure out what orders or what token? They already know what tokens they're going to trade, but how do you figure out like what is the price and quantity of these two items? And so that comes with our peer protocol, where the taker is able to send a message to the maker because they have the address. So the maker at this point doesn't know anything about the taker, but they know that they have at least posted an intent with the indexer. So they at least have these tokens on hand in their wallets. So the taker is going to ask for a get order. And what a get order means is that the taker is saying, okay, I would like, let's say, I would like a 2 of token A, and I can pay token B. And so they're not actually addressing any sense of price or any sense of, they're only saying what do I want? And it's up to the maker then to send back or provide an order back to the taker. And so what that looks like is that you send one message. So the taker sends a message to the maker saying, I would like 2 token of A, and I can pay token B. And so the maker will provide an order back to them with a particular price and quantity. And from there, they can, if the taker approves of this order, the taker can actually go immediately to execute that order. And to go into a little bit more in depth of what that order is, it's actually going to be a signed transaction, which will have all of the information required to execute a trade with our smart contract. So it's going to have the 2 token addresses, token A and token B. It's going to have the addresses of maker and taker as well. And the maker is actually going to sign the entire message itself, which ensures that the taker is unable to modify the order that has been given by the maker. And so that means that the taker can't just get one quantity and change it up. Go ahead.
So for, like, how does the taker know that they want 2 token A for their token B? Like, how do they know what their token B would be worth, I guess?
They don't. So they're just saying, I would like 2 token A and I can pay token B, but they're not specifying how much of token B that they're going to pay.
Oh, I see.
That's
Okay.
actually a piece of information that when the maker provides the order back to them, they're going to tell them exactly how much they need. And the taker then can be like, okay, do I have this amount, or do I think it's a fair price that the maker is telling me to take?
Is this part already on-chain? Like I would like 2 token A and I can pay X amount of token B, or empty amount of token B. Is that a message that is sent on-chain?
No, that's off-chain right now.
So the first
part of
that's
swap,
all off-chain, right?
That's all off-chain. That's correct. So the indexer, as well as the peer protocol, is off-chain, but the order that the maker now provides to the taker, which does get signed, cryptographically signed, that ensures that the taker is then able to send an order or send a transaction to the smart contract, which has all the pieces of information to actually do an execution and actually do a swap between token A and token B. Because, as I mentioned, you're going to have the addresses of both maker and taker. You're going to have what is the quantities that you're going to be trading. And you're going to also have the the actual prices, and you have a full order at this point. Does that make sense? Great. And so the nice thing about our smart contract is because we're using ERC20 tokens, which is a framework or a set of standards that is provided by Ethereum, there's a function called transfer from, which enables a contract itself to actually execute the trade. By execute the trade, I mean it is able to transfer tokens or some amount of quantity from token A to token B, and vice versa from token B to token A, without relying on any sort of central party to do this handling. And which is why we're able to complete this all with a smart contract, as opposed to having like a single person or a single party do the transfer for us. So that kind of takes care of one aspect of the peer protocol. The other aspect of it is, let's say you're not really looking for an order, maybe you just want to get some price information. You can also call something called get quote, where you're just going to get quoted a price. And so that brings it back to Celine's question, where it's just like, okay, are you going to get a list of all of these addresses? How do I know which one I want to take? And so one way you could do this, you could call get quote for all of these different makers, find out what price they're quoting at, and then pick the best price that you've been given. And so that, I guess, is one way that you can use get quote to get a better sense of what price is available to you. The second way to do this is that's going to come into our Oracle protocol, is that the Oracle is almost like a third-party source, again, off-chain, which will, if given 2 tokens, will give you what we think is a fair exchange price for those tokens. And we're calculating that with just using some pieces of market information. And we enable that both the maker, the taker, or anybody using the swap platform is able to call Oracle to get prices about these, or exchange prices about these between 2 tokens. And so this diagram actually shows you that one approach that a maker and taker could take, if the maker doesn't really know what price that they should be offering, they could get an order, know that they have to give back a price to the taker. They are unsure about what they should be offering, so they go to the Oracle and be like, hey, can you tell me what price I should be offering to the taker to do this trade between token A and token B. The Oracle will send them back some price, and so then the maker will be able to give that price back to the taker. The taker can also, if they're unsure about what price the maker has requested of them or what exchange amount that they've given, they can also call the Oracle and be like, did this person give me something that's fair, or is it something that maybe I should ask somebody else, another maker, to get a better price, because clearly this person is asking me for something that's more unreasonable, or that's unreasonable. So that's the behavior of the Oracle. So at this point, the full flow of what goes on for a order is that you start with an indexer, which will allow makers and takers to get joined with each other. From there, the taker can send a get order to the maker, and that they have an interest in purchasing some token A, and they're willing to pay token B. Maker will send back maker can either check with the Oracle to get a fair price, or if they're pretty confident about the price that they have, they can send it to the taker, and the taker at the end can decide, I'm going to execute what's been given via a smart contract, which is our exchange contract, which will do this swap between token A and token B. Does that aspect of everything make sense? Go ahead.
So at what point does a maker approve the smart contract to withdraw the amount of tokens?
So yes, both the maker and the taker will have to call and approve prior to the smart contract being able to execute those amounts. And so that'll take place around, I guess, once they've sent the order and that they know that the taker can potentially execute their amounts. So they will approve it. So one thing to note is that there is an expiration on the order. So this order is not going to be just sent out to be around forever for the maker. So once it expires, the maker can kind of withdraw their approval.
What if like someone just there's like 2 orders that are pending, and if they were both executed, they would like deplete the taker balance whatever tokens, like there wouldn't be enough to fill both of them.
Right. So
And so what determines like which one gets executed if they're both submitted at like at the same time, or like?
So in terms of when you say who gets submitted first and which one would execute first, it would be depending upon the smart contract for which has decreased the balance. So based on how the Ethereum blockchain works, usually it's whatever goes into the block before would actually have the first depletion, then the second one would fail. You can't really have a negative balance for these balances.
How could a taker haggle with a maker in this case? Like, is there room for the taker to send the offer that the maker gave to them back and potentially haggle? Or is it kind of like once they get the one offer, they can either find somebody else, or like how would that work? So in at least this current version of the protocol, there's not too much negotiation that occur from what's been talked about now, but the addresses like maker and taker, the taker can actually become the maker. There's nothing stopping them from actually posting their intents and being able to, instead of taking a price that somebody else is offering to them, they can actually give out the price that they would seek. So there's that flexibility to handle the case that you've just mentioned. Now I'm going to talk just briefly about the smart contract and how it handles the actual transfer for these balances, because that kind of ties into where you'd mentioned, yes, there's an approval process and how the transfer would actually take place. So with our smart contract, it is fairly simple in that we're working with ERC20 tokens, and so they all kind of follow the same. They're similar functionality, and they also all carry balances for individual addresses for different parties. So there's going to be a maker address and a taker address. Because ERC20 tokens, to be able to do a transfer or to be able to withdraw, for a smart contract to be able to withdraw quantity from token A and token B and then send it to respective parties, it does require that both the maker and the taker call approve to the smart contract to allow this withdrawal process to occur. And so the maker would have to call the approve before they send it to right after they send it to the taker, to ensure that if the taker were to execute the order, that this transfer would take place. Because if that did not take place, then the transfer would fail and there would be no swap done. And just note that it is an atomic swap, so even though we are doing two transfers, if one of them fails, it won't be left in a state where one person has gotten quantity and the other one has not received their appropriate swap. I guess that kind of goes over the basic motions of like what is swap doing, how is it handling the trading between two parties, what is the mechanism for how that's happening, which is via the smart contract. Now I'm just going to talk a little bit about our token, and then again open up for any other questions. So our token, really, what having our token allows you to do is it allows you accessibility to use our swap platform. There's, as you guys might know, if you've done work with Ethereum, there is gas required or transaction costs required to execute transactions onto the Ethereum blockchain. And so the fact that we're having a swap token means that you would lock in a minimum amount of your token into our platform as a way to almost use our platform. So outside of Ethereum, you could think of that as basically like a licensing fee or something. And this is just a one-time fee to allow people to use our ecosystem. And from there, you wouldn't actually have to handle the transaction fees, because that's almost takes place by owning and keeping the minimum balance within our platform, which is kind of really, it's a unique idea, and it's also just, it's convenient because then it means that people don't have to worry about individual costs, which can add up if you do multiple trades on other platforms. And that kind of brings up some of the reasons that maybe swap is, oh, go ahead, Aspen.
So wait, how are the transaction fees handled then if like they're kind of like covered, you said, if you buy swap tokens?
Yeah, so like because you're interacting with it via our swap platform, you would get less transaction fees than you would if you were to have to do these trades or use other platforms to handle those transactions yourself. And I guess, so back to my point about why using swap is more affordable, as well as you get more privacy by using it. Because we have this one-time fee, you don't have to pay for all the transactions, which is nice. It means that if, for other exchanges, if you were to just put the entire trading onto a blockchain, that means that you would constantly have to pay for every time you wanted to do a trade, every time you wanted to do any message passing onto the Ethereum blockchain, and that those expenses would add up tremendously. And then the other part is this indexer and peer-to-peer protocol. The communication is happening just between those two. So the indexer is going to find those two parties, and then the peer protocol where you're actually going to negotiate or determine what price you're going to execute at is happening privately, which means that there's not an issue where if all of this was in a public space and all put on a blockchain or in a public ledger, it means that maybe miners or other individuals would not be able to see that information beforehand and take action upon it, which could almost front run or manipulate or impede like a fair trade to occur. So those are like two of the benefits. And then you also just get a nice discovery to kind of find new parties to trade with.
Yeah, so will the peer protocol and the indexer, those off-chain protocols, how much of that will be open sourced, and how much is? I guess the question is, can someone else set up a server and run a similar thing?
Yeah. So what we're providing, right, is a protocol, and so with protocols, while we might start at first to build it out just to show as an example, and that is our product. Both the indexer and peer protocol would be available for people to use, and so they can put their own modifications to it however they see fit. The same if somebody else wants to create an Oracle process. They could do a different way that they're going to get a fair price or a price that they think others are going to use. So at that point, it is up to the maker and taker to kind of, we're just starting this ecosystem for all of this to work. But that's not the end. It does allow for people to build up on what we're doing and kind of put their own implementations for however they see fit. So that basically wraps up, I guess, what I wanted to talk about for Swap and kind of what we're doing.
Yeah, just had a question about when the maker makes those offers, are they able to basically take those and price out how they view the tokens? And how does that interface with the Oracle and determining, the price that they want to gain from what they have? And does that cost transaction fees? Okay,
so for your first question, it's up to the maker if they want to even talk to the Oracle or if they don't want to talk to the Oracle. Like, it is possible for the maker to come up with their own pricing mechanism, and so they don't actually have to communicate with the Oracle. The only reason that maybe they'd be incentivized to do it is that maybe the Oracle can determine prices in a fashion that maybe the taker would be more likely to accept. And then you ask about transaction fees. So the actual Oracle and finding out the prices, all of that's being done off-chain, and so there would not be transaction fees that are occurring on Ethereum to get this pricing information. The only amount that you have to pay is to be able to use at least what we've currently built out for Swap would be that single licensing fee so that you could use those different function calls if you decided to use them. Does that answer your different parts?
Definitely. And just to follow up, could the maker just basically use a bunch of the takers to determine a market value of their token and just not execute any transactions? So just using the indexer and peer protocol for like a pricing?
Yes, they could. They would, I guess, clearly not be using the maker would, from what they would get, right, they would just get information from the maker of what tokens they want to get. The maker itself, though, is the one who's actually providing the prices. So I think in your case, if somebody just wanted to get prices for things, it would actually be the taker who would be doing this, right? So the taker could constantly be asking different makers for different pieces of price information. And you're right, at some point they might decide never to execute any transactions. They might never decide to execute any swaps. And yes, that is possible. They're probably not using the platform for how we had intended it, but we're not going to stop them from doing that, because you're right, people can just use our platform to get better price information, and maybe this is a better liquidity source for them if they'd like to use it.
In the provide order ABI, there's a nonce mentioned.
Yes.
That the maker sends to the taker. So does that mean the maker has to wait? If I want to trade different kinds of tokens, do I need for one token to go through, or nonce needs to be executed in increasing order, right? So it might happen that if I send out multiple things.
So this might be, so the nonce in this case is not the actual nonce that is pushed into like a regular Ethereum transaction. We're using a nonce as just being a random number. And the way that we're using our nonce is to ensure that the taker doesn't just execute two of the same orders from the maker twice. So again, it's just it is a different interpretation for like how we're using the word nonce, because I realize nonce as well, for Ethereum transactions, you have to do them sequentially, and if you miss the sequence, you actually have to wait for them.
I was just wondering if you can describe the token a little bit more. From my understanding, like you said, it pays for transaction fees, but so are you saying the taker isn't paying gas fees to execute that smart contract, or are you saying the token is used to subscribe to like the peer-to-peer network and to use like the indexer? Yeah, so I was just wondering like what transaction fees you're referring to, and yeah.
Sure. So the swap token specifically is used as a way to be able to use our swap platform. The swap platform is, as you mentioned, the ability to use our indexer, the ability to be able to find maker and takers, to be able to use the oracle, and then ultimately be able to send a transaction to the smart contract. And because this is all kind of happening within a web application, we're able to kind of take those costs away from somebody who has to use them.
Is there a kind of singleton smart contract that all makers and takers use?
Yeah, so this smart contract is just, think of it as just a contract that is able to do the exchanges for, like it's just kind of handle the exchanges that are going to occur between the maker and the taker address. And because we're just working with ERC20 tokens, it means that any ERC20 token, if we're given the correct addresses and token values, or addresses of the makers and takers as well as the tokens addresses, we're able to execute on the same smart contract each time.
Okay, so it's just one smart contract for all makers and takers.
That's correct.
Okay.
Have you thought about how to prevent like DDoS attacks? Or I once read about high frequency trading, and like that many people create a bunch of orders and then delete them right away and then create them again, and like to spam the system and be the only ones to actually know what kind of orders are real, and that way be the only ones to trade. So with the indexer, you said you run the indexer, but in theory it can be run any indexer?
Technically, other people, well, technically anyone else can kind of put up an indexer if they'd like. And I guess you brought the point, like, okay, what happens is like a single individual pushes up a whole bunch of messages, several intents without really doing something. Yeah. And at that point, like the indexer would have to kind of block that, as well as kind of like, that's the reason, I guess, for one reason to do it off chain is that to handle the management and ensure that you kind of stop those DDoS attacks, or else reduce the frequency of them. I guess we can kind of block them if we're able to. So it goes, I guess, with the implementation of the indexer.
So I think so specifically with the indexer, there's the fact that makers are posting intent, and so there's also potentially like a reputation element. So if somebody's posting intent and then failing to serve that intent by actually providing orders, then potentially an indexer could implement something where there could be some kind of rating, for example. But then like a denial of service attack is potentially something else, and then that of course would be based on whatever operational protections the indexer has actually implemented on their end.
Cool. If there are no more questions, thank you guys for kind of watching and I guess learning about Swap. If you have any additional questions, feel free to ask me offline or anything. But yeah, thank you guys.